Well, hello everybody. Here are the notes for section 2-1. Of course, we took the test last time and I gave those back today, but these will be the video notes for section 2-1. It's over what we call domain and range. Overall, a pretty easy topic if you remember it from your Algebra 1 days. And then I need to review with you function notation. So what I did wind up doing with them in class today is I answered any questions that we had, mainly over the test, of course. Then there's the materials that I covered. You will need in front of you your class notes for this video. If you have those with you, you're going to be set to go. And of course, that's my page for answering questions, but here goes. This right here is not on your worksheet, not on your worksheet. But what we cover today is called relations and functions. A relation is any set of ordered pairs. So what I did here, guys, is I just gave you some sets of ordered pairs. 1 and 5, 2 and 6, 3 and 4, 4 and 5, 5 and 4, 6 and 6. You can kind of read them and see what you think. Some terminology that we need. The x values in all of these is called our domain, also called our independent variable, but we use the word domain the majority of the time. The y values is our range. So for instance, if I picked any of these ordered pairs, if I asked you to give me the domain of this set right here, you would just do this. You'd use a capital D to represent domain, and you'd put the braces, so the cool parentheses, and then you would just list the x values. You'd say, I got an x value of 1, 2, 3, 4, 5, and 6. To list the range, I'll do the same thing. I'll do a capital R, though, colon, brace. Now you just list the y values. 5, 6, 4. Since 5's already listed, I don't need it again. Since 4 is already listed, I don't need it again. Since 6 is already listed, I don't need it again. That's all there is to it. Now, a relation becomes a function if and only if, that's what that ISS stands for, I didn't misspell the word if and only if each element in the domain corresponds to exactly one element in the range. It also passes the vertical line test. Here's what this means. It's a function that if you tell a story about the ordered pairs, if it could happen in real life, then it's a function. So look at my first ordered pairs. I got 1, 5, 2, 6. See if this could happen in real life. On the first day of cross-country practice, I sent the guys team 5 miles. On the second day of cross-country practice, I sent the guys team on a 6-mile run. On the third day, I sent them on a 4-mile run. On the fourth day, a 5-mile run. On the fifth day, a 4-mile run. And on the sixth day, I sent them on a 6-mile run. Even though that's a lot of running, that could happen in real life. So this verse right here would be a function. Check out my second one. I got 675, 775, 875, 975. Pretend this scenario. At 6 in the morning one day, it was 75 degrees. At 7 in the morning, it was 75 degrees. At 8 in the morning, it was still 75 degrees. And at 9 in the morning, it was still 75 degrees. Just one of those days where the temperature just held. This could happen in real life. So this here is a function. But now picture this one here. I'm going to use LeBron. In the fourth game of the basketball season, LeBron scored 11 points. In the fifth game, LeBron scored 12 points. In the sixth game, he scored 21 points. In the seventh game, he only scored 8 points. And in the fifth game, he scored 15 points. And you're sitting there thinking, well, yeah, this could happen in real life, but this one's not a function. And I'll tell you why. There's a contradiction right here. Notice that I said in the fifth game of the season he scored 12 points, and in the fifth game of the season he scored 15 points. There's a lie somewhere there. So that means it's not a function. The other way to tell if it's a function, domain cannot repeat. The domain cannot repeat. Your ranges can. Your ranges can, because notice that example right there. So the ranges could repeat. Let me go over to the next page on your notes. These will be on your notes. Once you know what a function is, then we can classify it as either one-to-one, onto, or both one-to-one. So if you will, your class notes right there in front of you, it's a one-to-one function. Here's the mathematical definition. Each element of the domain pairs to exactly one unique element of the range. Let's clean that up just a little bit. Add this definition, if you would. If the range is used, it's used only once. So if the range is used, it's used only once. So we look at our y values. D was used once, B was used once, C wasn't used at all, but that's okay, and A was used once. So this is called one-to-one. On2 says this: each element of the range also corresponds to an element of the domain. Okay? What's this mean in layman's term? Every range is used. Every range is used. That just means every y value is used. It becomes both one-to-one if this happens. Kind of makes sense. Onto means everything's got to be used. One-to-one means each guy only has one partner. So equal domain and range. Equal domain and ranged, each used once. So there's what we got on that. That's that box on your sheet. Now I'm going to pick the pace up a little bit because it's really pretty easy here for a little bit, guys. It says for problems 1 through 8, state the domain and the range of each relation. Then determine whether the relation is a function. If it is a function, determine if it's one-to-one, onto, both, or neither. So here's all we're going to do. I'm going to put a capital D for domain, and then colon, and then the brace, because we're showing the world a set of numbers. Now just go through and list the x values. They happen to be 0.5 or 0.5, 0.4, 3.1, and 0.4. Technically, I did not need to list this one again because it's already used. While I'm here, since a domain was used twice, this thing is not a function. To finish it up then, the range is just going to be the y values. So it looks like I got a 3, a 2, a 1, and a 0. That's all there is to it. Here's another simple one. My domain, so capital D, colon, brace. Now let's just go through and list your x values. -5, 4, 3, -7. Since none of these repeated, this thing is a function. While I'm here then, let's list the range, which would be all the y values. There's a 2 in there. There's a -2 in there. There's a -11. And there's another 2, but I didn't list that again. So we know it's a function. Now, if you will, look on the top of your sheet. We need to decide if it's one-to-one, meaning if the range is used, it's used only once. Well, it's not one-to-one because the 2 was used twice. So it's not one-to-one, but it is onto. The reason it's onto, every range was used. If you have a set of ordered pairs, it has to be onto. So there's what we got so far. Let's take a peek at number 3. I'm going to fly through it really fast. Capital D, colon, brace. Looks like I got 0.5, 0.1, and 6. What do you think? Is it a function? No domain repeated, so yes, it's a function. Let me list the range now. The range looks like -3, 12, and 8. Okay. Hey, now on this one, it says if the range is used, it's used only once. No range was listed more than once, so it's definitely on 2. Now I'm going to see if it's 1-to-1. Each element of the range is used. So yep, so this thing is both. It was 1-to-1 and on 2. Okay. And then just to fly through number 4, I'm sure you got the hang of it. Capital D, colon, cool parenthesis. Looks like I've got a -15, a -14, a -13, a -12. None of those repeated, so I know this thing's a function. Now let's list the range, which looks like a 12, an 11, a 10, and a 12 is used again. A 12 is used again. Since a 12 was used twice, it's not 1-to-1, but it would be on 2. If you have a set of ordered pairs, it's going to be on 2. Let's peek at number 5 and number 6. Number 5, we're just going to list the domain and range. Another way to show it to you, I could show it to you as dots. Hey, no big deal. The domain, guys, is still the x values. So I'm going to start from the very left. My first x value is a -4. I have another x value right there of a -3. I've got another x value right here at 0. My next x value happens at 1, and then there's a 3. None of those repeated, so yes, it's a function. The range, I'm going to just do the same thing. I'm going to start from the far left again, but I'm just going to list the y values. That y value is a -2. That y value is a 1. This y value is a -2, but I already got it. This y value is a 2. And that y value is a 3. And then if we look at our definitions, it says if the range is used, it's used only once. Well, a -2 was used twice, so it's not 1-to-1, but it would be on 2. So that's what we got going on this. Hey, now number 6 looks a little weird. The domain says, hey, what x values are you using here? Well, if I plotted this point, guys, it looks like I got the point 1 and almost 3, not quite 3. I got 2 and something. I got 3 and something. I got 4 and something. I use every x value in the whole wide world. When we write that, we're going to just say for one of two ways. I'm going to say that it's the all real numbers, or normally what we'll do is I'll do this. I'll say the domain is parenthesis -infinity to +infinity. That's the cool way to list all real numbers. The range will also be -infinity to infinity. So just different ways to list things. If we look at the definition, if the range is used, it's used only once. That's true. And it is 1-to-1. So this is going to be both. So that's what we got going so far. That should clean off the front side of your class notes. If you will, scroll over to the back side. And remember, guys, if I ever get going too fast on one of these, you can always hit pause if you need to. Rewind, whatever you need. Here's what we're going to do on number 7. We're still going to play the domain and range game, and we're going to see if it's a function or not. So what we're going to do is we're going to graph the line y equal 1/2 x minus 3. Two ways to do this. One way is we could plug in numbers. I just made up some numbers for you. -4, -2, 0, 2, and 4. I'm going to plug -4 into here. So I'm going to grab my calculator or my brain. I'm going to go 1/2 times -4 minus 3. And I'm going to run that through my calculator. Well, I know half of -4 is -2. Minus 3 more gives me a -5. If I go 1/2 of -2, which is -1, minus 3 more, I'm going to get -4. 1/2 of 0 minus 3 is -3. So all I'm doing is plugging them in. You're just grabbing your calculator, going 1/2 times 2 minus 3 equal, and your calculator is going to tell you this is -2 and -1. Okay. Now we're just going to graph these. So I'm going to plot the point -4, -5, which is right here. I'm going to plot -2, -4. I'm going to plot 0, -3, 2, -2, and 4, -1. So there's that. Let's connect the dots. So there's that graph. And then it also says, determine whether it's a function or not. Well, no x value is shown twice. So my domain in this case, -infinity to infinity. My range in this case is also -infinity to infinity. This thing is a function because no x value is repeated. And in this case, it's going to be both 1-to-1 and on 2 again. Because if you go back to the definitions on the front side of your paper, if the range is used, it's used only once, no y value is listed twice. And every y value is used. So there's your number 7. Peek at your number 8 if you would. We're going to graph x squared minus 3. This is going to be a quadratic, also called a parabola. So I need to point out something to you because some of your calculators are different. If you're going to run -4 squared minus 3, some of you will need to place it in parentheses. So you might check your calculator real fast. The correct way to type this in for most of you will be parentheses, plug that -4 in parentheses, square it, close your parentheses, square it, minus 3. You might grab your calculator and type that in. You should get 13. If your calculator gives you -19, you for sure have to put that in parentheses. If your calculator doesn't give you -19 and it gives you, if it gives you 13, then you're going to be good. Now when I plug -2 in there, I'm going to go parenthesis, -2, close the parenthesis, squared, minus 3. Whenever you raise a negative number to a power, you need parentheses. When you do that, guys, you should get a 1. And then just to save you time, when I did this, I got -3, 1, and 13. Let me graph this. I got -4, 13, which is going to be way up here, so I'm not going to plot that one. I've got -2, 1. I've got 0, -3. I've got 2, 1. And there goes my parabola. And notice I put arrows on there, guys. It shows the world that it goes on forever. Now, in terms of domain and range, the domain says what x values can you use. What you got to do is look at your x values. If you drew a vertical line through your x values, you got to ask yourself, would it hit the graph? So when I draw an x value through 4, as I go up, will I hit the graph someday? You bet. So I use a -4. Would I use a 5? I'm going to go up. Will it hit the graph sometime? Yep, it will. My domain then is -infinity to infinity. The range though on this one is a little tricky. Excuse me. The range says what y values are being used. Well, the littlest y value that I'm using is right here at -3. That's the littlest y value that I use. So my range written in function notation looks like this. I got a closed bracket. I got -3 to infinity. So there's what we got. This thing is a function because no x value is used more than once. It's not one-to-one because some y values are used twice, but it would be on 2. Okay. You'll like the rest of this because it's pretty darn easy once we got past that domain and range. So hang with me for about another 5 minutes. This is not on your sheet, but it's a shortcut. When you're given a graph, there's an easy way to tell if it's a function or not. It's a shortcut, I call it. And it's called the VLT, which stands for the vertical line test. Here's what it says. It says if you can draw a vertical line and only hit your graph at one place, no matter where you place that vertical line, it's going to be a function. So like when I look at vertical lines here, guys, when I draw it, I only hit this graph in one place. If I drew my vertical line over here, I only hit this graph in one place. If I draw it out here, I only hit that graph in one place. So this one right here would be a function. Compare that to this one over here, though. Look what happens when they draw a vertical line. When they draw a vertical line through x = 1, it looks like they got an answer of 1 and maybe 1.5 or something. And then they also, when they did it, though, they got an x value of 1, -1.5, give or take on the y value. Notice that the x value was listed twice. That's what the vertical line tells you. If you draw a vertical line and it hits it more than once, that means your x value will be used twice. Okay? My next slide is not on your notes, but it's going to take us about 1 minute to go through all these. Determine if the following graphs represent functions or not. So look at this first one. When I draw vertical lines through here, I'm only hitting this graph at one place per line. So yes, this is a function. But check out this next one. I could draw a vertical line right there and only hit it one time. But I could draw a vertical line right here and I hit it 1 time, 2 times, 3 times. Since it fails the vertical line test, I'm going to put not a function. What do you think of the next one? Vertical lines only hitting it 1 time, so yes, this is a function. What's your thoughts on the parabola? I'm hoping that you said it's a function. And then how about the last one? Not a function. The reason being, it will fail the vertical line test. Bam. I just hit it twice. That means that x value is repeated. Now my last little piece, I need to review with you because you've seen it before in algebra. I just want to review with you. Need to review with you what's called function notation. We did problem number 9 already. If you look back on your number 8, if you look back on there, I gave you y equal x squared minus 3. And I gave you this little chart where I asked you to run through -4 and -2 and 0 and 2 and 4 if I remember right. Here's the same problem written in function notation. This and this are the exact same thing. Notice number 8 said y equal x squared minus 3. Number 9 says f of x equals x squared minus 3. So here's the rules of this game. You can pick any letter that you want right there. A, B, C, D, E, F, G. A lot of times they use F for function. This tells you what variable that we're going to use. We decided to use a x. It says f of x equal x squared minus 3. To find f of negative 4, it just says this. Go plug in negative 4 in place of the x. So I'm going to go parenthesis, negative 4 squared minus 3. When I run that through my calculator, I got 13. Remember earlier on number 8 when we filled that out, we had a 13 there. F of negative 2 says, go plug in negative 2 where there's an x. So I got negative 2 squared minus 3. And once I did that, I had a 1. When I went 0 squared minus 3, remember, we got a negative 3. And then this was a 1 and a 13. So that's all it means. Whatever's sitting right here, you're going to plug that in for x and simplify it. So look at my, kind of my next to the last little group here. I'm going to tell you f of x is negative 2x plus 4. So I got negative 2 times x plus 4. If you can do it in your head, more power to you. If you can't, that's okay. So on number 10, to find f of 12, I need to go negative 2 times 12 plus 4. You can run that through your brain or your calculator. I'm hoping you use your head. Negative 2 times 12 is negative 24. Negative 24 plus 4 yields me negative 20. Number 11, f of 6, I'm going to go negative 2 times 6 plus 4. Run that through your brain. I got negative 12 plus 4 more, negative 8. Number 12, f of 2b. It means throw away your x and place a 2b in there. So it looks like this. Negative 2 times 2b plus 4. When I simplify this, I got negative 4b plus 4. There's your answer. You can't combine those because they are not like terms. And it looks like I have a typo here. This should be f of negative 5d. So to do this one, I've got negative 2 times negative 5d plus 4. Negative 2 times negative 5 happens to be positive 10d plus 4. These are not like terms, so stop. Don't try to solve it because there's no equal sign with it either. Okay. And then last but not least, my last 3 here, guys. Or last 4, I'm sorry. F of x, ooh, this time I called it g of x, big deal. I decided to call this function g. I decided to use the letter x. And I've got x cubed minus x. So here's what you're going to type in your calculator. I need to take 5 to the 3rd power minus 5. So on most of your calculators, you'll go 5 caret 3 minus 5 equal. Some of you will go 5, and you should have a x to the y or y to the x key. So you'll go 5 y to the x3 minus 5 equal. If you do that correctly, you should get, if you want to make sure you're using your calculator correctly, you could pause the video and run it through real fast. 120. On number 15, since I'm using a negative number and a power, here's what you need to do. Go parenthesis negative 2 to the 3rd minus negative 2. You can run that straight through your calculator. So I'm going to get negative 8 plus 2, so that's going to yield me negative 6. Number 16, to find g of 7c, throw away the x's and put parenthesis 7c. So it's going to look like this, parenthesis 7c, close your parenthesis to the 3rd, minus 7c. Now to review from your Algebra 1 days, this means 7c times 7c times 7c minus 7c. So what you need to do in your calculator is take 7 times 7 times 7, or 7 to the third power. So I'm going to get 343 c to the third, because c times c times c, you add your exponents, is c to the third, minus 7c. There's your answer. As weird as it looks, there's your answer. And last but not least, g of 2b means, parentheses, 2b to the third minus 2b. So to simplify 2b to the third, it means 2b times 2b times 2b. 2 times 2 times 2 is 8, not 6. b to the third minus 2b. And then stop. These are not like terms, so that's your answer. So guys and gals, that's what you missed for section 2-1. Good luck on your homework. If you have any problems, buzz in and see me before school or during seminar. Good luck to you.